prototyping and training and things that are near and dear to my heart. We have a booth set up. We're 3D printing hopes and dreams over there. You can check it out. The cool thing about that 3D printer is that we teach you guys how to build it. So if you're interested in learning how to build your own 3D printer, drop by. All right, so this is a little bit about us. There's a little walk down memory lane for those who have been in Iraq and in Afghanistan or have worked with the REF. That's where Albert and I, Albert's also with Building Momentum, we cut our teeth in rapid prototyping. So next slide, you're going to see a lot of pictures and not much text because I don't like lots of small text on the screen. So essentially we cut our teeth in rapid prototyping by being deployed for the REF, doing this in situ on the ground with the warfighter. A lot of us come from technical backgrounds, PhDs in electrical or mechanical engineering, or in my case, I'm a chemist, which means I don't fit in anywhere. But we did a lot of this on the ground, making products, making prototypes for the warfighter, and that has spawned this company that we have now. Next slide. There's Albert on a satellite system there, tweaking it in Afghanistan. We also worked with the REF's mobile labs, which you'll hear more about tomorrow from Veteran Corps. They are going to be talking a little bit about the mobile labs that they help the REF employ and deploy. Next slide. So I'll get to the training in a second, but one of the things that actually, just to plug us for a moment, what we do really well is product development when it needs to be done rapid and quick. So again, we did a lot of this for the military, and we know how to make products fast. The prototypes fast, the reason that makes sense is, let's say you needed to get something fielded really quickly, or you're risk mitigating some technology that you're trying to decide whether you want to build internally or not. We're probably not great at making a refined permanent product if you want to take that through the cycles, but we're good at making stuff pretty quickly. But I'm just going to throw some pictures of things that we did while we were overseas and deployed. We can talk more about this offline if you see something that piques your interest. Yes, we didn't make the MRAP, but we did make the poles that go over the MRAP. Another thing that we do in consulting is we consult with people on how to make maker spaces and mobile laboratories and things like that. We've lived in these labs for so long that we know how to make and design them, so we also consult with people on how to do that. Right now, our clients are pretty much schools and public places like libraries that are looking for help in making maker spaces there. So here's what we do best: training and education. And I know the talk talks about 3D printing. We use 3D printing a lot. Albert and I have had our hands in just about every 3D printer out there, or at least most of the ones you've heard about as well. And what we realized is, for one, we probably need a 3D printer to make some of the things that we want to make, and that it also serves as a great textbook for teaching. So we run workshops on how to make 3D printers, all the way through to our technology boot camp, which you'll see a bunch of pictures here shortly on what that looks like. It truly is what I think we do better than just about anybody. After being downrange, after taking time with the warfighter, seeing what they need to have built, and then coming back, and then I ran the program that trained all the engineers and scientists that were going downrange to the REF at the time. And Albert and I enjoyed that part of it so much that that's where we focused the meat of the company, was on training and helping people develop these things themselves. So all of our training is project-centric or scenario-centric training. So why is that any different than anything else? Well, I don't like slides with lots of text on it. I actually don't like when people sit in front of slides in classrooms and learn things that way. I'm very hands-on. So all of our training that we do with anybody is completely hands-on, getting dirty, making things. The 3D printing workshop that we teach, we go to Home Depot and get the wood, and we laser cut the wood with you and start putting that thing together, and within a week you have a 3D printer that you can put on your kitchen table and print whatever you want. Everything in our training is challenge and event-centric too. So we try really hard to use competition. Everything from, in this case, these were engineers getting ready to deploy for the Rapid Equipping Force. They had PhDs and advanced degrees. They really get into the competition. In this case, it was a 3D printing competition, catapults and bridges, who can make the best, who can shoot the ball the farthest type thing. It's unbelievable how people turn on their A game when you have a competition. And on the flip side, Albert and I do work with inner city youth and at-risk youth, and in those situations, competition works just the same. These kids want to learn robotics. Not if you force feed it to them, but if you tell them, let's go beat the other guy, they ingest this stuff like crazy. So all of our training is that way as well. It's competition-centric or challenge-centric. Sometimes the challenge is we have to set up a surveillance system on a faux Afghan village that we've contrived. And when we've done that in the past, we've had airsoft mines and OP4 and all sorts of things to help the situation seem more realistic for the engineers. To just who can build a bridge that holds the most weight at the center line. All these things get people to consume the information really quickly, and they learn really, really fast. So in our training, a lot of these training events are a week long. We have done shorter vignettes of 2 and 3 days, but we really like the 6-day, 7-day training event. We have sent, maybe 80 people through this that have gone downrange total, and we've trained everything from soft to and sort of team operators to teachers to staff to green suiters, you name it. And this is, like I said, a small vignette of what that training covers in a course of a week. We like the intensity because it also bonds everybody together when you're doing something that's this intense, this long, and over the course of a week or so. For anyone who's been through some of the special teams, it's sort of like that Hell Week or Pool Week or something like that, where it's just intense all day, all night. So why is tech training so important? So you guys might say, hey, I got a software team. Why do they need to learn how to MIG weld? And the answer is they're probably coding for a reason. They're probably going to attach this code to something that is hardware oriented at the end, or they are going to interface with another team that thinks differently than they do. And so we've taken people through training that are orthogonal in the things that we're teaching them. So they are coders, or maybe they have no science experience or engineering experience whatsoever. But I think it really helps, especially downrange, but I think in any industry where everyone on the team has an appreciation for all facets of what you're working on. So yes, do coders need to learn how to TIG weld? Well, maybe not on their everyday, every day when they go to work, they're going to TIG weld, but it does give them an appreciation for what the hardware team might have to interface with. And as you go down that list that we saw earlier, things like microcontroller programming and open source coding and things like that, it helps the hardware guys to appreciate what coding is like and what goes into it. And really, at the end of the day, if you've gone through this training, you come away with a swagger. If you build a 3D printer, and by the way, I just recently, Albert and I took a 14-year-old girl through the 3D printer workshop, and in the same class, a 40-year-old librarian, they came away learning how to not only 3D print, but they have a confidence and a swagger about them that you just can't get from doing regular online training or looking at textbooks or things like that. So everything we do, it looks like a bunch of toys over here if you guys get a chance to take a look, but everything applies to things that can be either made downrange or rapidly, even within your own companies. The robotics that we teach, we have built many devices in theater, in Afghanistan and Iraq, based on the Arduino platforms that we use for robotics. It's just fun to make a robot, but the technology that you learn transfers. You can go to the next slide. So this is a very interesting point, and if you guys remember back in the day when like Commodore 64s were coming out and things like that, this is a really interesting point in technology, because when I learned to program, it was a VIC-20 or a Commodore 64, I don't know what you programmed on, but it was pretty rudimentary computers. and then it came this phase where it seemed like technology was getting more and more inaccessible. I look at the iPhone now and it's like, none of us are making that in our free time. But there's been an inflection point that has happened where technology is now accessible. You have something like this, which is just a little Arduino board and a little LiPo battery and some electrical tape and an LED. And Albert made this in under 15 minutes because I said we should make something for this to show people how easy this is. So this is a blinking light. Not that interesting. What's interesting is I could teach any one of you guys to make this in 15 minutes, and this is blinking at a rep rate that his camera can see. It's just a little webcam, pardon me, that any camera can see, and it'll distinguish it from other blinking lights. So we just made an optical tag in no time. And we did stuff like this all day in Iraq and Afghanistan when we were there. Now, I have a little packet of IR LEDs. If I put an IR LED on here, you guys would just think I'm crazy because it wouldn't do anything in your eyes. But it's easy just to swap those things out. What's really cool is when you empower a warfighter, a soldier, to make this. Now they don't have to order it. Now they don't have to come to you or come to somebody and say, I need some little tag made. You can just say, you can sit on the computer and program, this Arduino board. If you have it with you, you can order these on Amazon and get it. Actually, we got them to Afghanistan in 5 days. You can make this really fast. Now, is this a finished product? It's absolutely not. All you guys are showing, time machines and sharks with laser beams and things like that are pretty awesome. This is not that. This is not a finished product. It is something that you can teach someone how to make really quickly, especially in a moment of duress. They can get them off and running and then decide whether they need to make something later. Again, Albert made this under 15 minutes. I swear I can teach all you guys how to make 1,000 devices just like this by giving you the building blocks and some of the training. So why is the training important? Why us? We've been doing this for a long time, about 5 years of this type of intense, immersive sort of get your feet wet immediately training. And what you're going to see next as I sort of talk a little bit more about the training is just people that have gone through it and tons of testimonials. Go ahead. Sorry. I think I picked the wrong mint. You can go to the next slide. So 3D printers, if you guys haven't had a chance to understand or work with a 3D printer, they're a pretty useful piece of gear. They allow change to happen sort of forward, so you don't necessarily need to make everything now. But there's more than that. There's more than 3D printers that allow you to do that. There's microcontrollers, there's software, there's different types of hardware. There's a million sensors that you can, this board is one of hundreds and hundreds of sensors that are available to anybody on the open source market where code is already pre-written. And we just show people how to leverage that. So if you go to the next slide, you'll see more of the training where we teach this type of stuff, where we teach how to leverage what's already out there, how to put this stuff together really quickly, and then at least have something that you can go do your mission. Again, this has been a force multiplier we've seen, not just in 3D printing and not just in having gadgets and widgets, but now you don't have to order that thing. The soldier can go make it, the contractor can go make it, or anyone else in their corporations can now think a little bit differently and figure out how to go get to product faster. Go to the next one. So this training actually that you see right here was done at REF. We were training the next round of deployers, and they were learning, I think in this video, or in this picture, just how to build a robot that ran after a line, that followed a line. Is that relevant for downrange engineering? Maybe, probably not. But what's relevant is all the sensors that went into that. Now they used ranging and audio ranging. They did reflectance sensors. Now you can imagine all the insidious things that you can make with the sensors they built just in using this robot, and it all translates. Again, these guys they're all engineers. They're all either degreed, masters, or PhD level guys. But this was all new to them. And these are people supporting the Army. It's such a powerful thing, the open source community. Such a powerful thing to understand how a 3D printer actually takes a file and converts it into something. But what's even more important is the training behind how to leverage all that stuff. I mean, this is $11 worth of stuff. You can make all sorts of fun tags with this, especially using an IR LED. You're off to the race. I mean, if you guys know the Firefly, how many thousands and millions of Fireflies have been made with just, all you do is you swap this with the IR LED, then now you have a Firefly. Now someone can make this, you don't have to buy them. Next slide. So we've, actually in this picture, it's great. One of the guys there is a scientist, and one of the guys there is a former SOF team member. Not sure which one it is. Actually, the guy on the right is the nerd. But we like to pair these teams up too. When we do a lot of our training, we try to pair the operators with the scientists. When we train teachers and when we train some of these other groups, corporate groups, you don't obviously get that chance, but it's really great to have that dynamic, especially when you contrive the missions to be outside, to be a little bit more fantastical. Go ahead. So, a couple of these slides here are just, again, reiterative of the same thing, but I just can't stress enough how important it is to train your staff, to train the people going downrange on all these other options that are out there. If you don't know what this microcontroller can do or what a 3D printer can do, or I have a little vision sensor over there that's tracking my pink Millennium Falcon, which we also 3D printed, which is another cool way, another reason to make 3D printers, by the way. You can print Star Wars stuff, but it's using vision sensor to track the Millennium Falcon. That has 1,000 applications in tagging that I can only dream up a dozen of them, and you guys could probably go with the rest. But that stuff is all open source. I can show you all how to build that in a matter of a few hours. This was a good one because we did a lot of training with non-commissioned officers with our scientists, and these were teams that deployed downrange. But it was also, again, this juxtaposition of non-tech and high-tech, and it produces these great teams. And the solutions are always better than all tech or no tech. So again, if you're thinking, Brad, what is this, you're talking about downrange stuff, I'm making a radar, I have a company that makes a radar, or I have a company that does electroluminescence. Think about what it's like to cross-train those teams in areas that are maybe even orthogonal to what you're looking at, because it truly increases. I mean, just look at the testimonials here. It truly increases the productivity of your team. So again, this was another one of these events where we had them take a bunch of steel and get over a 10-foot wall with some contraption they had to make in under a few hours, and then it had to fit back down into a box. And so people came up with ladders of different sizes and different shapes, and then in this one we made a twist. We had to have them put an antenna on the top of it for another project that dovetailed into the final big project at the end of the week. A lot of our training is that way. It's small projects that dovetail into a larger multi-day project at the end. And so people are exhausted, they're fighting, we're working out conflict resolution issues, and I love that stuff. So we look to see how to optimize that type of communication across those people. Go ahead. Just two more slides, I think, on just groups that we work with. It's not just military, it's not even always just professional. Sometimes we run workshops and training events for kids, for parents that are interested. The guy with the kid is actually a NASA rocket scientist who wanted to bring his kid in to learn robotics with us. We train teachers. In this case, we did a big week-long teacher training event where they came in and did the same thing, actually, that most of our military and defense training went through. This was an urban canoe they had to build, so we taught them how to make weld and TIG weld in the morning. They had never seen a welder, didn't even know what welding really was. And in the afternoon, they had to build a canoe or some device to race 100 yards with multiple turns. And they did it. I mean, these teachers were afraid of a welder, and then they were welding like crazy, and also strategizing on the board, and people would step up and have different responses, and there was some infighting, and all these things we would break down and talk through and help them in their team building. You can go to the next slide. So again, this is sort of this is the last fun picture slide. Just showing that table, that crazy table of disarray. That happens in every training event we've ever done, but it also happens downrange. It shows that there's a lot of different things going on. Creativity is spewing out, and you make a giant mess. But there's a lot that can be garnered from this type of training that applies to downrange. It applies to logistics, because the more you empower the people forward, the less they have to buy down on the backside, the less they have to rely on the things that are at home. And there's so many things you can do with the technology that's available. Again, we're in an inflection point in history when it comes to technology. It's getting easier and easier. I can take this board and make a radio out of it in probably just as much time. There's so many cool things that are emerging. If you guys have heard things like Raspberry Pi, Arduino, there's all these BeagleBone, there's all these devices and things that are coming out. They're now accessible by everybody. You can go to the last slide. This is actually a picture that Wes Bryn took of a teacher welding. So it's one of my favorite pictures, but she had never even thought about ever welding, and here she is TIG welding. So I just want to conclude with just keep that in mind, as far as not only if you're putting people in harm's way, if you're trying to build something for the government, if you're just thinking about you have a startup and you want to improve the training of the team. But there are many ways to take this training and tailor it to what you guys need for your companies and for the mission and for the need. But it truly is a force multiplier. You enable the people downrange, you enable the people forward doing the mission on how to innovate like this, and I mean, not like this necessarily, but innovate, and then you have now reduced their burden on the people back at home. All right, that's all I had. I can take questions or get back to 3D printing.
Thank you, Brad.
Sure.
Okay, our next presentation